Students, next topic is thermoelectric effect. So in this video we are going to learn three types of thermoelectric effect, that is Seebeck effect, Peltier effect, Thompson effect. First, what is meant by thermoelectric effect? The conversion of temperature differences into electrical voltage and vice versa is known as thermoelectric effect. So what is meant by thermoelectric effect? Conversion of temperature differences into electrical voltage and vice versa is known as thermoelectric effect. That is the conversion of temperature differences into electrical voltage and the conversion of electrical voltage into temperature differences is known as thermoelectric effect. Here the thermoelectric device generate voltage when there is a temperature difference on each side. A thermoelectric device generate voltage when there is a temperature difference on each side. If a voltage is applied, it generates a temperature difference. When the voltage is applied to the thermoelectric device, it generates a temperature difference. First, we are going to discuss Seebeck effect. Seebeck discovered that in a closed circuit consists of two dissimilar metals. Seebeck discovered that in a closed circuit consisting of two dissimilar metals, when the junction are maintained at different temperatures, an electromotive force is developed. The current that flows due to the electromotive force developed is called thermoelectric current. Okay, according to the Seebeck effect, in a closed circuit consisting of two dissimilar metals, when the junctions are maintained at different temperatures, an electromotive force is developed. The current that flows due to the electromotive force developed is called thermoelectric current. The two dissimilar metals connected to form two junction is known as a thermocouple. What is a thermocouple? Here we are using the two dissimilar metals and forming the two junction. So the two dissimilar metals connected to form the two junction is known as a thermocouple. Students, you can see that picture for the Seebeck effect, that is a thermocouple, right? Here one is iron and another one is copper. Here by using the two dissimilar metal iron and copper, we made the junction. That the junction is also maintained at a different temperature. Here it is heated, here it is placed, one junction is placed in ice cube, one junction is placed in heat water. Okay, so the two junction are maintained two different temperature. If the hot and cold junctions are interchanged, the direction of current also reverses, hence the effect is a reversible. Here the Seebeck effect is a reversible effect. The magnitude of the electromotive force developed in the thermocouple depends on the nature of the metal forming the couple and the nature of the metal forming the couple and the temperature differences between the junction. Okay, the magnitude of the electromotive force developed in a thermocouple depends on the nature of the metals forming the couple, the nature of the metal forming the couple and the temperature differences between the junction, temperature differences between the junction. Next, application of Seebeck effect. Seebeck effect is used in thermoelectric generator. It is used in thermoelectric generator. These thermoelectric generator are used in power plant. It is used in power plants to convert waste heat into electricity. Okay, friends, these thermoelectric generator are used in power plants to convert waste heat into electricity. This effect is utilized in automobiles as automotive thermoelectric generators for increasing fuel efficiency. Students, this effect is utilized in automobile as automotive thermoelectric generator for increasing fuel efficiency. Here the automotive thermoelectric generator is used to increase the fuel efficiency. Then the Seebeck effect is used in thermocouple and thermopiles to measure the temperature difference between the two objects. Okay, students, it is the Seebeck effect is used in thermocouples and thermopile to measure the temperature differences between the two objects. Students, next topic, Peltier effect. In the year of the 1834, Peltier discovered that when an electric current is passed through a circuit of thermocouple, heat is evolved at one junction and absorbed at other junction. This is known as Peltier effect. According to the Peltier effect, when the electric current is passed through a circuit of a thermocouple, heat is evolved at one junction and absorbed at other junction. This is known as a Peltier effect. This is a circuit diagram to explain the Peltier effect. Here we consider two dissimilar metal, that is a copper and iron, and it is make two junction, that is A and B. At first, here the battery is connected to the copper wire. We take the current is flow from the copper to iron. When the current flows from the copper to iron, the junction A, it becomes cold junction. The junction B, it becomes hot junction. In the second diagram, now the terminals of the battery is changed. The current is flow from the iron to copper. When the current flows from the iron to copper, the junction B is become as cold junction. The junction A, it's become hot. So in the copper iron thermocouple, the junction A and B are maintained at the same temperature. At the initial position, here we made the two junction A and B. It is are maintained at the same temperature. When the battery is connected, let a current from a battery flow through the thermocouple at the junction A, where the current flows from the copper to iron. The current flows from the copper to iron. A becomes cold. At the junction B, where the current flows from the iron to copper, the heat is liberated and it is becomes hot. When the directions of the current is reversed, the junction A gets heated and the junction B gets cooled, as shown in the figure. Hence, Peltier effect is a reversible process. Now, students, next topic, Thomson effect. Thomson showed that if 2 points in a conductor are at different temperatures, the density of electron at these points will differ, and as a result, the potential difference is created between these points. Okay, according to the Thomson effect, if 2 points in a conductor are at different temperatures, the density of electron at these points will differ, and as a result, the potential difference is created between these points. This effect is also reversible effect. This is a picture to explain the Thomson effect. Students, here the Thomson effect is classified into two types. One is positive Thomson effect and another one is negative Thomson effect. So first I am going to explain positive Thomson effect. If current is passed through a copper bar AB, which is heated at the midpoint C, the point C will be at higher potential. Okay, so if a current passed through a copper bar AB, which is heated at the midpoint, the point C will be at higher potential. Here the potential is greater at a point C. Okay, we consider one of the copper bar AB. It is heated at a midpoint C. When the I current passing through the conductor at the midpoint, it has a higher potential. This indicates that the heat is absorbed along AC. Here it has a higher potential, so this indicates that the heat is absorbed along AC, and the heat is evolved along CB. The heat is evolved along CB. Thus, the heat is transferred due to current flow in the direction of the current. Thus, the heat is transferred due to the current flow in the direction of the current. It is called positive Thomson effect. Okay. It is called a positive Thomson effect. So, the positive Thomson effect means the heat energy transferred along the directions of the current through the conductor. It is called a positive Thomson effect. Okay. So, the similar effect is observed in a metal like silver, zinc and cadmium. So, here in a metal, copper, silver, zinc and cadmium exhibit a positive Thomson effect. Exhibit a positive Thomson effect. Here the heat energy transferred along the directions of the current passing through the conductor. There is a positive Thomson effect. Next, negative Thomson effect. Here, a metal iron, platinum, nickel, cobalt and mercury exhibit negative Thomson effect. Exhibit negative Thomson effect. Okay. So, when the copper bar is replaced by the iron bar, the heat is evolved along CA and absorbed along BC. See the diagram? Okay. Here this is a iron bar. AB is a iron bar. Now it is heated at a midpoint C. The current passing through the iron bar. Here the heat is evolved along AC. Okay, we can measure the temperature of AC means the temperature of AC is small. At a point C, the potential is lesser. The potential is lesser. Here, the point C, the heat absorbed, the heat energy is absorbed along CB. So, the heat is transferred due to the current flow in the direction. The heat is transferred due to the current flow in the direction opposite to the direction of the current. The heat is transferred due to the current flow in the direction opposite to the direction of the current. It is called negative Thomson effect. It is called a negative Thomson effect. Okay. So, the similar effect is observed already I taught to you in a metal like platinum, nickel, cobalt and mercury. Thank you students.